All right, guys, graphing exponential functions. I'm going to do this a little bit differently today than I normally would do because I'm not going to get to see you in class tomorrow. So I'm going to give you this just exactly what you need to graph these exponential functions, and hope you see a pattern and can make it go. Your assignment for this video will be on delta math, and I'm going to talk about using that a little bit as we go through the video, like how you're going to graph this on delta math so you can turn it in. And let's just go and see what happens here. All right, first one says graph f of x equals 2 to the x minus 2 power. It's an exponential function, obviously because the x is in the exponent. That's what makes it exponential. The graph is always going to take this kind of shape, either this way, like this, if it's exponential growth, meaning that number, the base is bigger than 1, or it may do this, may come down like this, if the base is less than 1, like if it's 1/2 or 1/3, if it's a positive fraction. If it's negative, something else happens. Obviously, if it's negative, it's going to reflect across the x, like we talked about with our gestures. So here's what I want you to do. Every one of these has a horizontal asymptote. That's going to be a big deal when you get into delta math. They all have horizontal asymptotes. The asymptote, if there's no vertical shift, if there's no number outside there to shift it up and down, your asymptote is going to be on the x-axis, which means your graph is going to get closer and closer to the x-axis, but it's never going to touch it. Now, they're going to make you graph 2 points, which is what I would do too. If I were teaching you this in class and we did this on graph paper, I would make you do 2 points. So the first point, what I want you to do is always go up 1 from your asymptote, up 1, right on the axis. Like right now, I'm thinking I'm right there, but there's a -2 in the exponent, which means it's going to shift that point right too. So one of my points is going to be right there. I'm going to make that a little bit bigger at the 2. You always go up 1 to there, and then if there's a shift in the exponent, you shift from that point. So it's 2. Now, that's 1 point. I need you to find 2 points. The other point, what I want you to do, once you find that first point, once you find this first point right here, right there, I want you to go 1 to the right, which in this case is going to put me at 3. So I want you to take the 3 and plug it in for this x right there. Plug the 3 in. Okay, every time you do that, that's going to make that exponent become 1. I promise every problem you do, that exponent is going to become 1, which gives me 2 to the first power. So what just happened is I plugged in 3 and I got 2. So that's my next point, 3, 2. Right there it is. There's my 2 points, my red one and my green one, just like Christmas. And so to graph it, I'm just going to connect. Remember, the graph is a curve. It looks like this. If you think about it, there's nothing I can put in for x that's going to make that 2 become negative. That's why this is an asymptote. That's why we'll never go below the x-axis. And your graph is going to do that shape right there. It's going to look just like that. And that's all there is to it. But on your delta math, when you get there, you're going to have to move the asymptote where it goes and move the 2 points where they go. Okay, let's try another little tougher. This one says 2 to the x minus 4. Now the minus 4 being outside shifts your graph down 4. Whatever number is outside there is really your asymptote. So your asymptote is going to be down here at -4. Your whole graph got shifted down 4. Now remember, we need 2 points. 1 point, remember, is always 1 above, right there. We're going to start there. This time there's no shift in the exponent left to right, so that point's going to stay right there. That's one of them, 1 above. To get your second one, again, I want you to go 1 to the right. Right now I'm at 0. If I go 1 to the right, I'm at 1. So I'm going to plug a 1 in to that exponent right there. And when I do that, it becomes 2 to the first power. It becomes this, 2 to the first power minus 4, which is -2. That's my second point, 1, -2, which is right there. And I'm going to connect the dots, just like this, and draw my graph. So I'm hoping this is making sense. The number on the outside is going to give you your asymptote every time, and you need to find your other 2 points. I got 3 more to show you. It'll get a little tougher as we go. Just hang in there. I think this isn't too bad. Hope you're getting it. This one says -1/2 to the x power plus 5. Now the first thing I notice is there's a plus 5 out here, which means my asymptote has been shifted up 5. So the asymptote this time is going to be way up here at 5. Drawing that. Now, the negative, what the negative does, remember we've talked about this over and over. A negative reflects your graph across the x. I'm sitting here doing a gesture in on my desk right here. Negative in the front reflects across the x, which means it's just going to turn my graph upside down. So what I'm going to do is, I'm going to, instead of going above the asymptote to put my first point 1 above, I'm going to put my first point 1 below. Look at your exponent. There's no shift in the exponent, so there's my first point right there. It's 1 below. Now, I keep telling you, your second point, go 1 to the right. I'm at 0 right now. So if I go 1 to the right, that puts me at 1. And what you do with the 1, you put it into your exponent. And when you do that, you get this. You get negative 1/2 to the first power plus 5. And if you work that out, you get negative 4.5. So my next point is 1, negative 4.5, which is 1. Negative 4.5 is way down here. Wow. And the graph's going to go like this. It's going to get closer and closer to the x-axis over here, and it's going to come down in a hurry. It's exponential decay. That's called exponential decay. When it goes up, it's called exponential growth. You should have been hearing about exponential growth right now with the pandemic because the number of cases is growing exponentially. They grow really, really fast. So that's what the graph looks like, exponential decay. 2 more. All right, this one has yet one more thing. I put a number in the front this time. So always start out here. Start there, plus 2, that's your asymptote. So I'm going to draw my asymptote at 2. There's my asymptote. The graph cannot touch us. Everything's positive, so it's going up. Now here's what this does. The number in the front, if it's bigger than 1, is a vertical stretch by 2. So my graph's going to get stretched up 2. So usually, I'll start right here. I'd go 1 above. But this time, 2 things are going on. One is this. I've got a -1, which is going to shift it right 1. I've also got a 2 in the front, which is stretching it up 2. So I'm going to go up 2 and right 1 from the asymptote. I'm going to do that one more time. I'm going up 2 because of that vertical stretch. I'm going right 1 because of my exponent to get my first point. The 2 out here tell me where my asymptote was. All right, you need my other point now. So right now I'm at 1. This point's at 1 on my x. I'm going to go right 1, which puts me at 2. All right, if I put 2 in that exponent right there, it gives me this. 2 times 3 to the first power plus 2. So really just multiplying the numbers out. 2 times 3 is 6. 6 plus 2 is 8. So I plugged in 2. I got 8. That point is right there. All right, draw your graph. Close to the asymptote. It's going to go up. I kind of missed that point right there. Let me try that one more time. I hate to leave it like that. So starting it here, going up through that one, up through there. That's exponential growth. That's what you're hearing about on the news if you're watching any news right now. Exponential growth. Okay, one more. Okay, this one has everything also, except it's got a negative in the front. So you know what that's going to do. That's going to reflect across the x-axis. So this one right here, -4, that is your asymptote. So I'm going to draw the asymptote, my horizontal asymptote every time if it's exponential at -4. All right, now, because there's a negative in the front, instead of going above by 1, I'm going to go below 1. I'm going to go below 1 right there, except it's really a 2 there. So I'm going to go down 2. And I'm looking at my exponent, which has an x plus 3, go the opposite of what it says. So I'm going down 2, left 3. There's my first point. Remember, we're doing 2 points. To get my second point, again, I'm going to go 1 to the right. This point is at the -3. If I go 1 to the right, I'm at -2. And I'm going to take a -2 and plug it right there into that exponent. So I get this, -2 times 2 to the first power -4. And your job is to work that out. So -2 times 2 is -4, -4 is -8. So there's my second point in -2, -8, which is way down here. So when I draw my graph, it's going closer and closer to the asymptote, and it's going down just like that. And that's all there is to it, guys. I hope that's a lot of examples. The video, you can review the video, you can go back and watch it again. The main thing is getting your asymptote and getting your first point. Once you get those 2 things, your second point, you're just plugging in the next number to the right. Should not be that big of an issue. Hope that makes sense. I didn't get to teach you as much as I really wanted to, but that should be enough to graph those. Please, please, please text me if you need me. Your assignment will be on Delta Math. Good luck with that. Text me if you're having trouble with it, and I'll give you some help. Missing you guys. See ya.